So, hello and welcome back to my C++ tutorial playlist. In this video, I want to cover how to structure bigger projects into modules. This is a little bit misleading because we are not talking about C++ modules, but about logical modules, namely classes, header files, and so on. This is the code that we left off with last time. I again want to remove everything and start off with a blank project. We obviously need our main function. And then maybe let's create a very simple game. What we want to do is specify some classes. And for that we need a header file first. And we want to call this player HPP. And our player will have some functions. And functions inside a class will be called method. For example, it will have a method attack. This will take an enemy, and the return type of this function will be void, so nothing. Then of course it doesn't recognize the enemy, so we need to also create a class for that. And for now, the enemy will have a take damage function. And also this will return nothing. And it will have a private variable health, like that. I really want to keep this very, very simple for now. Also, this statement here only means that we only want to include this header file once in the translation unit. So everything that gets packed up together into one object file from the compiler. This is not a C++ standard, but it's common practice to use this, and it's implemented by every compiler that is common. Now when we included enemy HPP, we have now the ability to attack, and we might also want to take damage, be able to take damage. And for that we also need to have some kind of health. Then we maybe have an is-alive check. And a good practice is to annotate the things that don't change the state of your player with const, or the state of your class with const. And another good practice is to annotate anything that returns something with no discard. And that basically means that anyone who uses this method will be forced to make use of the thing you return. Now in our main, we could have a game loop. And for that, maybe let's first create a player. And for that, we do need to include the player header. And now we can do a loop while player is alive. We can maybe ask our user for input. And we can prompt our user for some input. Something very primitive and simple. And we can also create an enemy. And maybe not enemy is alive. Then we can print u1. And then we want to break out of our loop, of our main loop. And maybe just to indicate that we are stepping out, we can print game over. And this would already be a very simple game that is not functional yet, because we didn't implement the methods for our player and our enemy yet. Also, enemy is missing our is alive. So now it looks fine. Let me show you that it's not working. As we can see, we get undefined reference errors to all the methods that our game is trying to call. And that is because we annotated that these functions will exist somewhere, but we never created them. As we can see, we don't have a function body. And to implement these methods, we create an implementation file. These will have the file extension CPP instead of HPP. And here we will include our method declarations, like so, and like so. Of course, we didn't specify how to create an object of that type, so we need to also specify our constructor, and that will only take in float for health, and the same applies to enemy. And as we can see, a constructor doesn't have a return type, and it must have the same name as the class, like so. Also, what I want to show is that we can have static functions here, or methods, and these are independent of an object. I will show you what it means in a second. I will just return a string here. So with all of that, we can take all of our definitions or our declarations and paste them into our implementation file. And here we need to prefix them with the class name and provide a definition. And we have access here to the this pointer. This is a pointer that points to the current object. And this has access to all of the member variables that we specified within the class here. This would set the health that we have in our object to the health that was passed to us. A better way to do it might be with a colon and then the name of the member variable, then the initialization list curly brackets, and then our argument. And after that, we can specify a regular constructor body, but we won't utilize it in this example. Here, we need to create an implementation for attack. And for that, we will just use this, take damage, and of course, we also need to specify some kind of damage here. So let's take in some damage also. Damage. Of course, we need to fix it here as well. And as we can see here, we can't call take damage on the enemy because it's not annotated with const. We can check if it's alive here because that has the const annotation. If we want to call something that changes the state of the enemy, we need to remove the const here and also here, like so. And with that, we can move on to the next implementation. And as we can see here, we can return a string literal like this, even though this is a const char, and C++ is allowed to do one implicit conversion for return types and arguments. So const char will be implicitly converted to a string and will then be returned. Now we can move on to our enemy implementation. Like so. And now we can implement a very simple game. So here we now need to specify health. So let's give it 100 of health, and likewise for the enemy. And this should be float literals. But as we have learned already, C++ is allowed to do one implicit conversion. Here we can then input the damage. And maybe we allow the enemy to attack also. Player take damage, and we take that amount of damage each turn. One thing I forgot is I wanted to show you how static methods work. We can access a static class like this from the object, as we did with our other methods, as you can see, but we don't need to have an object to call it, because static methods are part of the class and not of the object. So with that, we should be already able to compile it, but one second, let me show you that we still get the undefined references, and that is because we didn't add it to our CMake lists yet. So here we just need to specify our C++ files, like so. So let's try it again. So as we can see, player has the type player. Yeah, the formatting here is horrible, but let's take damage 1, 1, 1, and so on. And game over. Let's fix the formatting a little bit and make the game look a little bit prettier. So for that, we can use print line here, and we need to specify a space here. Then we might also want to display our health information here. So now if you would compile and run it again, we can enter damage. So let's say 12 cores. What we forgot is to actually print the information that we implemented. And that would make sense here, maybe. Like that. Also build again and run it again. So let's again enter 12. And as we can see, the player HP is now this, and the enemy health points are this now. So let's do 44. The enemy HP are 44 now. Let's do 55 again. And now we won because we killed the enemy. That's a very, very simple game, but I hope it clarified how to use classes. What we've seen here is that player and enemy are very similar in the operations that they provide. So they can both take damage, info, and have an is alive. Maybe they could do even more things to get that are similar, but maybe let's just use these and abstract them away into an I entity. And this is basically base class that we can use for both of our classes, for the object and for the player as a base. And this basically is a contract that both of these have to implement. And we need to specify these methods as virtual and also set them to 0 to indicate that they don't have an implementation here, but they need to have one in the final class. So that means any child class is now forced to implement these and to make player and enemy a child class of identity. We also need to include it again, like so. And now all we have to do is specify it like this. And now all the methods in the contract can now be specified with override. So we make sure that we actually have overwritten them correctly. As you can see, we already get a warning here. So let's hit override here also. And this basically means that we have defined the functions that overwritten the implementation from the base class, which is here none. And we can do the same thing for our enemy. Like so. And what we can do now in our game is something pretty interesting. We also need to include int here. And of course, we see that we have a redefinition. And this comes because we didn't specify the pragma statement here, like so. And now we don't get a redefinition anymore. Now what we can do is change this here a little bit and just specify while true here, so it always runs until we return. We can specify you lost here. And now we can have the entity that one can be saved in a pointer. And as we discussed in a previous video, a pointer in C++ is basically just an optional reference. And in this case, the winner is the player, like so. And in this case, the winner is the enemy, like so. And game over, winner is. So let's extend this a little bit to also include a name. And let's really keep this very, very simple. I only want to have it implemented like so. Our base class already has a name, so we only need to set it. We already are an entity, so we have all the things that an entity includes also. So in our constructor, we can just say name is future player. And here, when we construct our enemy, we can do the same thing. enemy like this. And now if we compile and run it again, we messed it up because winner is a pointer, so we need to dereference it. So let's do it again. Damage 11. Let's just do this. So we won. Let's do it again. Now we only do very little damage, so we can lose. And now the winner is enemy. So much to that. And I think that has already been it for this video. I hope this has been helpful. And you should have some more tools in your belt again to tackle more complex problems in the near future. Don't worry, we will go over more complex examples and more practical examples in the following videos. Thank you very much for watching and see you in the next video again.